my presentation on Ulaştırma Yapıları, or as in English, transport structures or transportation structures. I will be doing my presentation hopefully in English. First things first, transport structures. What are they? Why do we need them? And what is the history of transport structures? As is in the picture, transport structures include but are not limited to trains, train roads, bridges, roads, tunnels, anything really that transports something or goods from one place to the other is called a transport structure. Continuing, we're going to be explaining the three keywords in our topic today: transportation, structure, and road. Going on with the definitions, the definition of transportation means the action of transporting someone or something, or the process of being transported. So you have something, you want to move it from point A to B. The act of doing this movement, of moving the subject, is called transportation. Now, the definition of structure is a building or other object constructed from several parts. It could be made from anything. It could be made from clay. It could be made from iron, wood. It's just a structure that you put together in an organized form. And structures normally could be artificial, man-made, or it could be natural. You can find in nature perhaps an anthill that makes a structure, or a tree could be considered a structure. A road is a pretty simple definition. A road, a wide way leading from one place to another. You have one place that goes from point A to B. This is a road that takes you from one place to the other. The road, today especially, a road means one for vehicle. We don't use the definition road for humans today. It's specifically for vehicle used. But in the old days, you could consider anything a road for humans, for cars, for animals. But today we use a definition more strictly, specifically for roads. So the history of transportation. The oldest wheel found in archaeological excavation was discovered in what was Mesopotamia, or modern-day northern Turkey, and is believed to be over 504,000 years old. But no one knows exactly who invented this. It's debated on which civilization specifically invented the wheel. Wheeled vehicles appeared later in various forms or areas across the Middle East and Eastern Europe. The technology spread quickly, transforming society as it went. Carts and wagons eased the burden of daily tasks like holding water, timber, and food. They also allowed people to travel over land with relative ease, turning the continual plains into a full way for trade, migration, and cultural connections. The earliest forms used animals to pull vehicles. Of course, when the mankind first invented the wheel, it was a breakthrough, a technology. This transformed society to where we see it today. It made moving easier. You no longer had to worry about getting so much tired. You can move your goods from one place to the another. It made civilizations bigger. It made them more connected. Civilizations now could trade between one another. Maybe civilization in the Middle East could trade with one in Mesopotamia, and so forth, or perhaps from Italy to Mesopotamia. Trade become easier, and as we read history, we can see presentations or examples of this, like the Silk Road between the Chinese Empire and all the way through the Roman Empire. We have evidence that the Chinese traders went all the way through to Roman Empire back in ancient days. And how was this possible? It was possible through cards, more specifically. And even if we look at the Roman Empire specifically, the Roman Empire was an empire that spanned across two continents, from Italy to the Middle East, or Italy to the Mesopotamian continent. And why was Italy so important or so famous? It was famous for its roads, its very well organized and paved roads. Yeah, so if we study the history, we can see a very clear sign that the invention of the wheel marks a clear dot in the history of mankind for making trades easier, life easier, movement easier, even not just trade, but even warfare. We today use the wheel. We have vehicles, tanks, and stuff that use wheels to move on. So, the history of structures. Humans have used one form or another of structures in history, whether it be for protection from weather, rain, snow, or cold, hard, or to sleep in it. well as temples for kings or to show their might. A structure is any grouping or organized shape, be it artificial or natural. Of course, today we can see in our cities we have many structures, buildings, any structure, man-made. We can go to the jungle, we see natural structures. So some examples of natural structures, it could be the beehive when the bees make it, or the leaf, or could be the hills, as we can see in the picture. These hills are made by the movement of wind and water over thousands of years. These are examples of natural structures. Moving on to the history of roads. Humans have always shaped their environment to better facilitate their safe transportation and movement. Early examples include for roads are, for example, the Roman roads that we mentioned earlier, that so neatly paved for them to move through. So why are roads important? Roads are important for many things. The most important ones are for economic development and growth. Of course, if you want to trade within your cities, you need roads. You want to make sure that your traders can move their goods and sell them from one city to the other. And this it requires safe and paved roads. In order to make a nation grow and develop, this also requires trade, trade between the cities. This requires roads, and faster transportation. Let's not forget, and it's also safer with the roads, and most importantly, it makes travel times very shorter. So the demand for paved road rose with the invention of the as the wheel was invented. This wheel in the ancient time needed some form of road to move on, and the paved road the Romans made was a very good example because they could move freely on it and better. The greatest systematic road builders of ancient times were the Romans, of course. As the saying goes, all roads lead to Rome. And the Romans were very conscious of the military, economic, and administrative advantage of good road system. Now, let's give an example of ancient Roman roads. The ancient Romans were famous builders. They left behind their many bridges, canals, stone paved roads, and other engineering masterpieces all throughout the Roman Empire. The vast Roman Empire boasted a very large and extensive network of roads. It is estimated that the roads in the network were more than 4,100 kilometers long, and over 85,000 kilometers out of these were stone paved. The road network was important in maintaining the stability of the empire and its expansion. The roads were used for transport from one location to another. Along the roads, it was permitted to walk, pass through, drive cattle and wheeled vehicles, or to engage in traffic of any kind. Roman technique for building roads varied depending on the geographical location, terrain, morphology, geological structure, and available material, of course. For example, different technical solutions were required to build roads in marshy areas or in areas where the road passed through a bedrock. Nevertheless, there were certain standard rules that were followed. Ancient Roman roads consisted of several layers. We're going to talk about them. Otherwise, you can see there were 5 layers of the road. So the first layer of the road was the foundation soil. And this is the very lowest soil foundation. The base on which a road was built was compressed to be compact and to avoid structural settlement and then covered with sand or mortar. The one that above it is called a stagman, a layer that was laid on the compact foundation soil, consisting of crushed rock of minimum generality of 5 centimeters. So the thickness of this layer ranged from 25 to 60 centimeters. The next layer above it was Rhodes. It was 20 centimeter thick layer consisting of crushed rock 5 centimeter in diameter. So it was 5 centimeter diameter spread over this water. The nucleus, a concrete based layer made of cement, or we call it today, sand, gravel. It was 30 centimeters thick. The summum dosum, if I read that right, the final layer, and it was a topest layer, it was consisting of large 15 to 20 centimeters thick brick rocks. Of course, the Roman Empire was known in ancient times. It was a huge empire, and what facilitated this expansion, this growth of this nation or this empire, was the roads. It was its transportation roads, more specifically, its transportation structures in the ancient time. And this led to the saying, all roads lead to Rome. And it was a very true saying in ancient times. Let's give another example of Roman structures. The aqueduct, the Roman aqueduct. What was it known for? The Roman aqueduct was a channel used to transport fresh water to highly populated areas of the Roman empires, the Roman cities. The aqueducts were amazing feats of engineering given the time period, of course. Back in the day, there wasn't such marvelous stuff, but the Roman Empire were pretty ingenious people. Though early civilization in Egypt and India also built aqueducts, the Romans improved the structure and built an extensive and complex network across the territories, across the Roman Empire. If you look, even today we have remnants of it in Turkey, in Italy. They are Roman aqueducts. It's feats of engineering. We call them transport structures for water, of course. Evidence of aqueducts, as we said, and they modeled in France, Spain. We can find them in Greece, North Africa, and Turkey today. Aqueducts required a great deal of planning. They were made from a series of pipes, tunnels, canals, and bridges. Gravity and the natural slope of the land allowed aqueducts to channel water from a fresh source, such as a lake or spring, to a city. As water flowed into the cities, it was used for drinking, irrigation, and so on. So, yeah, the Roman's aqueducts were transportation structures for water specifically, but the form definition of our structures, as you can see in the pictures, they were made as bridges. They could be used across various terrains, and they used gravity and the slope of the environment to transport water. So no machines were used back in the day; it was just natural. So let's go on how the aqueducts actually was. So the Roman water supply was made up of several layers. We have the source, the drop shafts, the tunnel, the aqueduct bridge. We have the siphon. There was the most important part of it, the arcade, and the distribution station. So let's talk about one by one. The source could be anything. It could be a river tap. It could be a spring. Anything really. There are many ways to get water into an aqueduct. The most common ones are spring boxes and well intakes, infiltration galleries or river intakes, dams, whatever. Any source of water really can put water into the aqueduct. Spring, the most common source, springs, of course, the most common source were for water, Roman aqueducts. River intakes were used occasionally, often because of fear of population. You don't want your common water to a city to be polluted, of course. Artificial created lakes as a source of water rarely, although they could have been used to equalize the variations in the seasonal flow rates of the feeding spring. The drop shafts, what they were needed. In some cases, when the source is high on the hills, it is necessary to make the aqueduct steep so the water comes down. In such cases, they used special constructions to avoid damage. Sometimes in a cascade setting, as we can see, one by one it comes. Sometimes smooth chutes or stepped cascades were used to dampen the wave energy when the hill is too steep. The water comes down really fast. You don't want this water to break your aqueduct. So what you do, you make cascading, you make it come down level by level so you can lessen the impact when it comes down the aqueduct. So we also have something, the settling basins. After the drop shafts came the settling basin. So the settling basins were built to get rid of all the kinds of pollution that were in the water and were mostly situated near the source of an aqueduct. So the settling basins was a place you go up or put the water in and then you put it to the drop. So you clean the water basically at the setting and then the water comes to the tunnels and shafts. So moving on to, we have tunnels or shaft. To prevent deterioration, a tunnel could be necessary for a number of reasons to prevent lining problems. There are odd examples of miscalculations in aqueduct tunnels to save time and to make more economic use of the labor force, etc. The Romans often used the canal way of tunnel construction in which multiple vertical shafts were dug over a hilltop, after which the bottom of the shafts were connected with each other. So moving on, we had the siphon, which was a very important part. We're not going to explain the whole thing, but we come to the very last station is the distribution station. This is the station where the was situated at the city, where this water would be distributed to the houses and many people living in the city to complete all their needs, perhaps for irrigation and cleaning or whatever. So moving on, we come to modern day structures, as in the autobahns in Turkey. As you can see, the autobahn sign and the road sign. The length of the public network in road is roughly 400,000, 26,000. 177,000 kilometers of paved road of it. The highways are 300,000, not much. But we can see the autobahn starts from Şanlıurfa and ends all the way back at Istanbul, or goes way back. So the next in our agenda is Japan's bullet trains. The bullet train, they are fast, energy hungry, and are shaped like bullets, of course, to pass through. The bullet train is a network of high-speed railway lines in Japan. Been in operation for 50 plus years. Uh, bullet trains, I can say, are very important for the economy of Japan. And today, they are long channel or network of bullet trains are crossing from across all of Japan. We can see bullet trains are today from a lot of countries in China, maybe in Korea. They will have their kinds of bullet trains. Of course, bullet trains are really fast. They move a lot of people in space, and they require a lot of energy and effort to maintain and use. The next topic of ours is bridges transportation structure. A bridge is a structure built to span a physical obstacle, such as a body of water, valley, road, or rail. Anything can be to move from one point to the other. Without blocking this path, of course, you want a bridge to go across something, across the obstacles, over, above it, not remove the obstacle. We don't usually do that. I will say so. It is constructed for the purpose of providing passage over the obstacle, which is usually something that is otherwise difficult or impossible to cross. There are many different designs of bridges, such as serving a particular purpose and applicable to different solutions. Designs of bridges vary depending on factors such as the function of the bridge, the nature of the terrain where the bridge is constructed and anchored, and the material used to make it, and the funds available to build it, of course. Yeah, so the most important factors in building a bridge is the terrain that it's on, what type of purpose we need it. All, is it going to be used for vehicles? Is it going to be used for humans only? These are all factors that need to be considered to make the bridge to get the funding. As we can see in the picture, and on the left side, the blue bridge, it is mainly used for human beings, so it doesn't need to be a very tough bridge or very heavy bridge. It doesn't need a lot of money to build it. It's a very simple form of bridge. It only goes across the river. So if you look at the right side, the white bridge, that bridge is used as is a very long bridge. It's made of concrete and it goes across the river or the lake or whatever it is. And it needs to be a bigger bridge because it needs to weigh a lot more because we have vehicles and humans coming across it. So moving on to the type of bridges, we're gonna explain three types of bridges. First of all, we have the beam bridge. Beam bridges are horizontal beams supported at each end by substructural units and can be either called simply supported. When the beams only connect across a single span, of course, the beam starts from one place to another. It's just simple beam, or it could be continuous. The beams are connected across two or more spans. When there are multiple spans, the intermediate supports are known as piers. The next type of bridges, we have the truss bridge. The truss bridge is a bridge whose leading bearing substructure is composed of a truss. This truss is a structure of connected elements forming triangular units. The connected elements, we call them, may be stressed from tension, compression, or sometimes both in response to dynamic leads. uh, Cantilever bridge. Cantilever are using cantilevers, horizontal beams supported on usually one end. Most cantilever bridges are a pair of continuous span that extend from opposite sides of the opposing pairs to meet at the end or the center of the obstacle bridge crosses. Cantilever bridges are constructed being using much of the same materials and technique as beam bridges. The difference comes in the action of the forces through the bridge. So to end our topic, the summary, bridges and structures, and we can see ropeway, or we could call them telefrics. They are all designed for transportation. They A transportation structure could be anything. It could move goods, vehicles, and humans from one point to the other. It could be a tunnel. It could be a bridge over an obstacle. It could be only for entertainment, perhaps, like a teleferic. It moves people from one place to another. Is a transportation structure. It could be a bullet train. It could be any train, any object. A transportation is any object that moves one thing or human from one point to the another is a transportation object. And this was my presentation. Thanks for watching.